þá næstur á svið Andreas. Við höldum áfram hérna á norsku línunni. Já, gaman að sjá hvað að gera líka í Noregi og hann vísaði nú til hans, hann Kristoffer Bugge, þeir sem voru fyrir hádegi, þegar hann var að tala generative design dæmið. Ég veit ekki hvort hann tekur það fyrir, eða hvernig verður. Hann segir bara já, hann ekki alveg búinn að læra íslensku.
I have no idea what you're saying, but probably.
Good. No, but you're going to do the generative design and talk about Infraspace and infrastructure.
Yeah.
Was there anything more?
Sounds good.
Sounds good? Okay.
All right. Ja. Gaman att vara här. And that's about everything I know in Icelandic. So unfortunately, this is going to be in English. And I had to translate the title of this conference when I got the invitation to speak. It felt a bit unfamiliar, but when I translated into digital civil engineering, I felt more familiar because that's a topic I've been deep into for the last 14 years. I'm Andreas. I'm the founder and CEO of the company from Norway called Infraspace, and we have developed a generative design platform for civil infrastructure projects. And I will try to use my presentation here to show you a little bit about what generative design is, the product we have been building, and how it's being used, and why one of our clients call this a game changer for road design. I used to work as a civil engineer myself. I used to be a BIM manager, a project engineer, responsible for development within the project. And too often, I think it was too tedious going from an idea to actually having a basis for decisions in the projects. To develop a proposal, an idea, can typically be going, maybe a sketch. An idea can be sketched on a map quite quickly. But then you might need to draft or model it to make it able to communicate. And we need to coordinate and maybe make some molds, put them together to be able to show to stakeholders, and also maybe do some analysis. How many square meters of agricultural land? What's the impact of this alternative? And then you do the documentation of how it turned out. And a linear sequential process like this can be extremely tedious, multiple people involved, and it's not that many people here in Iceland, so it can be challenging, as I understand, to get enough resources to do it properly. So this can be tedious, involve multiple tools, and can be a challenge. At least what I felt 5 years ago when I quit my consulting job to start and build new tools. And I believe that it has been a lot of focus going from in Norway at least, from going from doing the errors on the construction site to do the errors in the BIM model to be able to coordinate there. And that has really shifted the curve of where you do the coordination. And still, I believe it's time to focus on the early design stages, because that's where it often, the cost is locked in. But in the early stages of design, at least in Norway, it's typically still the same tools that we use for the detail engineering that is being used for the early stage design. And that can be a bit difficult. So that's why we believed 5 years ago that a new generation of tools is needed. We believed that accessible information for the right stakeholder is super critical, and the ability to do iterations faster is important to be able to work efficiently. And the data, just like was presented on stage later today, a lot of the data in the project is not even used in a way they should. And to be able to communicate effectively is also a key part of what we believe should be the next generation of tools. And the evolution of digital design in AEC also kind of represent what I've been through throughout my career. When I started working, I was actually making drawings on a construction site that actually Katrin was a part of constructing back in Oslo. But quite soon, 3D became the main format for delivery for construction sites. So we started doing a lot of focus in 3D CAD basically. And then there was a wave of BIM for infrastructure also in Norway. So we had to, some way figure out, and a bit painfully, figure out how to deliver BIM in infrastructure projects in Norway. And that could be quite challenging, to be honest. Quite tedious to make the models good enough to construct. So then I went super deep into a paradigm called parametric design. We were able to customize how we make the models and automate the processes. But the next step, as I believed it should be, is generative design. Or, as Autodesk put it earlier today, what they call outcome-based design. It's a process I will explain in this presentation now, but it's about putting your objectives at the start and using constraints and using your data and a new automated way of creating proposals to come up with better designs. And I dare to say that this is a technology that has the potential of doing things 10 times faster. There will be changes in how engineers and planners, designers are working with the emerging of AI. And at least in Norway and other European countries, it's often a discussion of how this will impact engineering, the emerging of AI. So I'm going to show you a short video of what we have been building for the last 5 years with Infraspace. So this video illustrates how you can quickly set up a project, add your data, models, and geospatial information, areas to take into account, and then you can start defining your problem. Set a start and end point, and let the algorithms, you set start, end point, geometric constraints, objectives, and then start generating proposals based on your objectives and your requirements. As for this railway example here, then you will get automatically generated proposals, 3D models, and KPIs. How well are your proposals performing? What's the earthworks? What's the land take? Everything accessible in a browser-based environment that you need to log into. So that is what we have been building, and that was also what was presented by Norconsult earlier today with some of their examples. And the core of what this platform can do is that we have developed generative design specifically for civil infrastructure projects. And generative design is it's a technology that's very well suited to explore options. Using your data and your computer and your problem definitions to then generate proposals that you can explore, communicate, and evaluate. So, when we built Infraspace, started building Infraspace, we wanted to take generative design, which is a broad concept that has been applied for architecture, automobility industry, and we wanted to do the same for civil infrastructure. So we then started out with processing the data that you have available in your project already, terrain model, geometric requirements such as radius, slopes, etc., geospatial GIS data, and then having a context where you can use that, define the problem, and then generate proposals and get 3D models, analysis, and reports directly out. So what we have been building is a standalone cloud-based platform, a web-based login interface where you can leverage generative design and get automatically generated 3D models. But to be able to take advantage of this technology, it's important for us to also fit into the existing workflows as well with existing tools that you're already using. So we have spent a lot of effort over the last years to make it fit into existing more traditional design tools. And the way we're seeing that this technology is being used by engineering firms in Norway is that they are using it to create proposals in a new way. But we also see that they use it for automatic analysis of the proposals they already have developed in a more traditional way by getting instant insight. And the third main use case we see is that they optimize. So taking their proposal, uploading into the platform, and optimizing. And one thing is to be able to do things faster, but that in itself is not the goal. But when we see that our customers is coming up with proposals that is performing better because they have a new way of working that's more efficient and work smarter, it's when they develop better proposals for a road with less costs, less carbon footprint, that is extremely motivating to see. And another example from Norconsult is where they have used Infraspace on a large project, a road project, highway project in Norway, where they have been using this technology during workshops to be able to generate alternatives that traditionally was more a pen and paper process. Then they were able to get instant insight during the workshop by being able to generate proposals on the fly. And also in this project, they were evaluating a large number of alternatives, multiple objectives they need to take into account. Then they could upload all the alternatives into the platform and they get them automatically analyzed within minutes, not waiting weeks to get the results. In this project, it was several objectives that they wanted to get answered. Carbon footprint and audiovisual impact, and what kind of land areas is important to how many square meters of wetlands, agricultural land. That was answers that could be given within weeks before, but within minutes using this automated way of doing it. So, and it's quite flexible regarding what kind of insight you want. So yesterday I traveled around, I visited some companies here in Iceland, and when I asked about what kind of areas is important to avoid when you're constructing roads, and I learned that elves was important to avoid. And I did some research last night in my hotel, and actually has been impacted the road projects as well in the history. So it's interesting to learn as well. But in Norway, we also have areas to take into account, like wetlands, cultural heritage, and that's the type of data that you can add into the system when you're generating proposal. And a few weeks ago, one of our clients gave us feedback that they were able to do a concept stage with 1/5 of the resources that they normally would do, because a lot of the process was more automated, and that they actually ended up with a proposal that, compared to a previous process, was actually 10% lower in cost. And that adds up for large-scale projects. And we started out with roads and highways, which was my background initially. But we have been, just as was said on stage earlier, we have been challenged by the engineers back in Norway, who are the front runners who want to push the boundaries. And they asked us, can you not do this for pipelines as well? Can you not do this for power transmission? And what about finding optimal sites? So we have been quite, over the last few years, been quite open to building something that actually is needed. So we have developed a platform to be able to use the same generative design concept into other civil assets as well. So if you're working on an energy project, just like a wind turbine project, you might have, even though that's not a transportation project, there's still extremely important to get the access roads in an efficient way. So for developing access road in a wind turbine energy project, you can then use the same platform to say, okay, these are my points where I have turbines, this is my access point. Okay, so I need to go up to this point and have this cross-section, this geometric requirements, maximum 10% slope or something. And then you can use this for automatic creation of proposals within a few minutes, typically. And then you can select, okay, this alternative looks interesting, and then get that automatically modeled with 3D models, along with KPIs, such as how many square meters of land take, how much rock cut, how much fill, and what's the mass balance. And for industrial projects, we have also developed how you can use the same concept, but to find optimal location. Could be a data center, an industrial building, a site, or a deposit. So in this client case, they had the location for a site, for an industrial building, but they wanted to challenge that existing proposal. So they then defined the shape that needed to be located within the area and said, okay, search within this boundary. And then they used Infraspace and Generative design to explore thousands of options with respect to the earthworks, different land take categories. And then they ended up with a proposal that actually had a significantly higher, lower cost and higher performance. So ended up with moving the location based on what they found. And for transportation project, we have multiple uses. And but one thing I'd like to highlight is that if you're working in a tender and have short time to do maybe optimization, get some fast insight, that is one particular use case that we see is very useful, where you can upload your existing proposal, use that as a basis for optimization, run a few thousand within your planning boundary, and then get instantly generated proposals based on what you had, but trying to optimize. And what we're doing here in the Nordics is actually creating attention globally. So we've been given awards for this technology and get feedback also and interest from all over the world, actually. And we see that this is technology that is definitely coming and definitely going to change how we can work as civil engineers. But it has been a topic of the talks I've been understood in English so far, that of course human beings is extremely important part of the picture. AI will not replace the need for civil engineers, but engineers who use their domain expertise in an efficient way, in combination with next generation tools, will have an extremely large advantage compared to those who rely solely on traditional tedious workflows and do not empower their expertise using technology. So using your expertise can look something like this, where you don't have to leave everything to the computer to solve, but you can say, okay, I have an idea. The road proposal should be about here. And then you can add your insight using your human and professional understanding and start making a sketch. Okay, something like this could be an interesting proposal. And then you can get feedback on that alternative instantly. We can also use that as a basis for running a few thousand options nearby. And then you can then select the ones that you think looks interesting, get them instantly modeled, analyzed, and then you can communicate with one another stakeholder in the project. So I believe that the future and the next generation of a project will be won by those who leverage their domain expertise in combination with the technology, and that is already happening. And but that requires change, and change can be a bit awkward, can be a bit challenging in many ways. Actually, changing and doing innovation can feel a little bit like stepping out into an open dance floor where nobody else is dancing. You like the music, you think everyone's going to dance at some point, but you need to be one of the first who has to step out. And that can feel a little bit awkward, especially when you're standing there and trying to dance and no one else is doing it. But when people join in, suddenly it will be normalized. And at some point, those who are sitting behind is the ones that can maybe feel a little bit awkward. And I believe that now it's a super interesting time in engineering where things are happening extremely fast. And there will, in very short time, be a difference between those who can say, I can evaluate 10 options at the same time, where one can do one. So if you're interested in maybe speaking about this technology, or share your thoughts of what you think is the future, I'm happy to connect. I'll be here the rest of the day, and happy to speak and connect with any one of you. Thank you so much for your time. Bye.
Thank you. We do have time for questions.
Yeah.
If there are any questions, you can also ask in Icelandic and check how well he understands that, or I can translate that, if there are any. Oli.
I know a little bit of Czech content from early days. I don't know the status of it yet, but is there severe difference in this against that capabilities?
Yeah. So as I mentioned about what I think is the next generation of tools, I think they will be cloud-based. I think they will be automating the model generation, and also I think they will be interactive, so you can add maybe sketches and to use it more creatively, not leaving it to the computer. But it's quite different. This is a cloud-based platform, whereas it's quite different. But especially the largest difference is how we're seeing it being used for different cases. Yeah. But of course, it's a computational way of thinking, both these tools.
Are there more questions? I have one. Since we had the presentation with Hannes and Viðar earlier, and I was wondering like how you do the road, so just to put you on the spot, would you be able to export your road project in a format so they could actually import it and you could do it in virtual reality?
Yeah, I was actually thinking about it when I saw your very nice presentation, by the way. So everything you see in these videos can be exported in georeferenced, commonly used open formats, such as IFC for these surfaces. So yeah, exactly, that can be done. Yeah.
You have a test project then to do. Yeah. Then, if there are not more questions, you can talk to him later in the break.
Yeah, just reach out. Thank you.
Thanks a lot. He said that we were together on a project in Oslo, actually on Dronningenfemiesgate.
That's right, yeah.
2012. It was the first 3D model project, but then we were talking about 3D models in infrastructure as CAD, but they just took CAD up to 3D.
Yeah, that's right.
Now we are over to BIM, generative or parametric design, and over to generative design.
Yeah, I'm happy to speak about all these stages. That's very interesting. Just to get in touch for over a coffee here.
Okay, cool. Thank you.
Thank you.
Thanks.